let's look at how we can do a two-sample, sometimes called an independent samples, t-test in Excel. So here we have data from two groups. These are stress levels, and we've got Division A and Division B. Division A is led by Al, Division B is led by Bob, and we think that Al might be stressing people out a little bit more. So based on this sample that we have, we want to make a conclusion concerning whether Division A is more stressed out than Division B. So our hypothesis is going to be a directional hypothesis. Division A is more stressed than Division B. That's a one-tailed hypothesis. And we're going to use, since the people that are related to each other are independent of each other, we're going to use this independent two-sample t-test, which is the most common t-test to use. And we're going to assume that the variances are the same. There's nothing that's going to make the variation in one group more than the other. So the first thing we're going to do is let's get some descriptive statistics. So we're going to go to Data, and then we're going to use the Data Analysis tool that you should have installed. If not, you should check out the video on how to install it. It comes free with Excel. We choose Data Analysis, and we're going to choose Descriptive Statistics. Press OK. Now the input range, let's get the descriptive statistics for both of them together. So I'll highlight both columns and then include all of the data there. They're grouped by columns. There's labels in the first row. And the output option, and when I click output option, I've got to click in the box there because the cursor went up there. And let's put them right here. And I press OK. Oh, that didn't work. Oh. Look at that. I didn't choose any options. We'll go back here and we need the summary statistics. And there we have some, let's round these off. Go to Home, General, Number, and we've got the stress for Division A and the stress for Division B. Let's insert a column between them. Insert. That makes it a little easier to read. Now let's make this up so that we make the columns wider so that we can read it better. And so the information that we especially need to know are the means. So Division A is 13.75 on the stress level and Division B is 9.63. We need to know the standard deviations because that'll enable us to tell how far, how different the difference in means are. That's a standard deviation. And then we've got the count, that's n. So n equals 8 for both of them. So we can tell that Division A is more stressed than Division B, but the question is it significant? Is this difference significant, or is what we could expect from just a small sample of 8 people? So what we're going to do is we're going to use the t-test in the data analysis. So we go to Data, Data Analysis, and then we're going to go to t-test two samples assuming equal variances. That's the broad one that we'll use a lot. And so we want to look at the two variables. We've got the input for variable 1 will be this first column, Division A. The variable 2 range will be Division B. So put all of those in there. And these have the labels in the columns, Division A and Division B. Now this hypothesized mean difference is almost always going to be 0. We just want to find out if they're different. We don't want to find out if there's a certain minimum difference between them. And for the output range, we click output range, click in the box there, and let's just put it over here. We press OK. Now let's make the columns wider so we can read them. And let's round off the numbers so that they're more user-friendly. And so we have the same information that we had before about the mean and the standard deviation. So we want to report those. The degrees of freedom are 14. We're going to need to report that. That's based on n. Since there are 8 plus 8, that's 16 minus 2 distributions where we calculated the mean. We've got the t-stat of 2.11, and we need the p-value. So this is a one-tailed test. So we're going to look at the p for the one-tailed. We've got the two-tailed down there too, but we only want the one-tailed one. And so its p equals 0.03, so it's significant. That's what's important, is that we found evidence that it's significant. It also gives you the critical value. We needed to get a t that was greater than 1.76, and we did. We got a 2.11. So how would we write this up in APA format? We could do something like this. The stress level of division A. Now we want to report the key descriptive statistics for A. The mean, and then space equals space, because you always put spaces around equal sign, like it's a separate word. 13.75. Standard deviation is the expression that we use in APA for the standard deviation, SD, equals 4.06. And then N equals 8. So that's the stress level of division A. Was hypothesized to be greater than the stress level of division B. Now we're going to report the same information for division B. Mean equals 9.63. Standard deviation equals 3.74. And then N equals 8. We tend to use small n's when it's a subsample of things. So we have two subsamples here, so we use the small n. And this difference was significant. And we want to report why it's significant. So we report the t value, and that t goes in italics, control I, t, control I. And then we put the degrees of freedom in parentheses. So the degrees of freedom was up here. 14, close parentheses, space equals space, 2.14, and then we put the p-value, and the p's in italics. P equals 0.03, and we can specify that it's one tail hypothesis. And there we have reported all the important data and our hypothesis, and whether our hypothesis was supported. And so this is how we do a two-sample t-test in Excel.